Good morning, good afternoon, good evening. Thank you for joining us today. I'm Miguel Mendez, marketing specialist here at Unravel Data. And before we get started, there are three housekeeping reminders that I would like to cover. The first is, throughout the webinar, please drop your questions into the question box, and we'll do our best to answer them live or respond via email if we're short on time. If you submit one of the top 10 questions during this event as ranked by one of our fantastic panelists, you'll earn some cool Unravel swag. Additionally, this webinar will be available instantly on demand to listen to at your leisure, so feel free to pause or replay as needed. And lastly, help us improve. Share your feedback on the session by rating this webinar, and let us know if there are any other topics you'd like to hear about. All right, that covers it. So with the reminders out of the way, the floor is all yours.
Thank you. My name is Chris Santiago, and I run the Solutions Engineering Group here at Unravel Data. I've been working with Unravel for about 6 years now, but no stranger to big data, with over 12 plus years experience, specifically working on modern data stacks. Unravel is a data ops and FinOps industry-leading actionability platform built for modern data stacks like Databricks. Today's topic is going to be about evaluating costs in Databricks overall for KPIs for cost management. More specifically, I'm going to walk you through some best practices on tracking costs defined by the FinOps Foundation, the leading organization comprised of some of the biggest data customers in the world. Then I'll walk you through how these customers are using these tools available to them today to track costs in their Databricks platform. And finally, how Unravel, the actionability platform built specifically for Databricks use cases, can make it even simpler to automate these best practices. Let's dive in. So, a bit about a history of the FinOps Foundation. It was launched in 2019, where the FinOps Foundation addresses cloud cost management by fostering collaboration across engineering, finance, and business teams. They joined the Linux Foundation in 2020, and now it offers standards, certifications, and a community-driven approach, guiding global companies like Adobe, AT&T, and Spotify in adopting FinOps practices, including Unravel. A key methodology is this concept of FinOps phases, and there's going to be 3 of them. The first one here is inform. This phase is about gaining visibility into cloud costs. It includes allocating costs to specific teams or projects, setting up real-time reporting, and establishing key performance indicators for cloud usage. It empowers teams to understand and track their cloud spend accurately. Next up, optimize. When organizations get to this phase, the focus then shifts to efficiency. Now that we have an idea in the inform stage where costs are being driven, was it a particular user? Was it a particular project or a cost center? And now we're starting to get that information in inform. Optimize is all about efficiency. Teams work on reducing waste, managing unused resources, and making cost-effective decisions. Things such as knowing when to use reserved instances at the cloud level, or maybe picking the right compute types that are sized for the particular workloads at the infrastructure level, or even going deep into the code and looking for fine-tuning of the code to maximize for efficiency. These are what the teams do during the optimize stage, and the goal is to maximize cloud value while minimizing unnecessary costs. Last but not least is this govern/operate phase. This phase emphasizes ongoing management and collaboration. Now that we know where the cost, where cost is being jacked up, now that we identified ways to optimize this, now let's make sure that we are operating on this. So teams establish governance processes. They leverage continuously monitoring spending, and they refine their FinOps practices based on usage and budget trends. So still, you don't stop at the govern stage. All of this is a flywheel. and it involves regular communication between finance, engineering, and operations to ensure financial accountability. Databricks customers today are applying these best practices with out-of-the-box tools provided by whatever cloud vendor that they're using and Databricks itself. So let's actually walk through this with you today. On the Databricks side, they just recently, in the last couple of months, announced the system tables. And system tables is a great way for understanding computation telemetry, jobs telemetry, and they've now started incorporating billing. The benefits here is providing some very good cost visibility at the Databricks level. So being able to provide detailed insights into cloud usage and spending across workspaces, allowing organizations to track and analyze consumption patterns. They also open up some use cases from an optimization standpoint. Now that we've got this granular data about clusters, now we can monitor for cluster usage, job performance, and query execution, where a subject matter expert can help identify efficiencies and optimize resource allocation. On this cost allocation front, what we can also do too is start to facilitate attribution of costs to specific teams, projects, users, enhancing financial accountability and supporting chargeback mechanisms. Now, all this sounds great, but there's always a few gotchas. And one of them is that Databricks is great at showing very granular cost details, but it's focused in on Databricks. And folks that are running these data platforms on Databricks know that there are other infrastructure costs, things such as the time that's spent on compute instances. That is not reflected here. So if you're looking for a true chargeback scenario to understand the all-in costs, well, you're only going to get partial view if you're leveraging Databricks system tables. On the optimization front, while it does allow subject matter experts to analyze this data, there is some manual effort to be able to first understand this influx of data, but being able to decipher it and identify areas of inefficiencies and root cause to realize these optimizations does require manual effort. So if you have some Databricks experts that can help you here, then you can really optimize from that standpoint. But if you don't, you're going to have to learn. Last but not least, it does not provide ways to operationalize or govern this from a bad behavior perspective. So while we can manually identify areas for optimization, how do you make sure that you are setting up best practices and ensuring that all of your users across the board are applying some of these best practices, making sure that they're making the right choices to be more efficient? It doesn't have these features and functionality out of the box. But other than that, very, very great addition to the Databricks library. And we encourage customers to use system tables if you're not doing that today. Next up is Cost Explorer. Now, I'm going to generalize this because this could be AWS, this could be Azure or GCP. They're all pretty much the same from that standpoint. You're seeing a screenshot from AWS. But the advantages that this provides is on that cost visibility angle, it does provide detailed insights into cloud usage and spending across all services. So we're not just talking about Databricks. We're also talking about networking. We're talking about infrastructure spend. So the Cost Explorer gives us that view. They also have budget management. So things such as setting up budgets, monitor spending, and receiving alerts for proactive cost control are things that you can do on the Cost Explorer. From an allocation standpoint, there is this concept of infrastructure tags. And so as long as the organizations are using those tags appropriately, you can now attribute costs to specific departments or projects. So to provide that further accountability. Now, let's talk about the gotchas on this one as well. While it shows us all in costs, what it lacks in is giving you the granular details into what of my compute resources was attributed to Databricks. And then if I wanted to understand at the user level at the department level, at the project level, this is where things start to fall flat. And so if we want to understand the all-in cost from a Databricks perspective, there's a lot of manual effort and a lot of actual, kind of combining data sets together to be able to get this information. So being able to get that fine-grained all-in cost is a challenge if you're using just Cost Explorer. And you can't combine this with Databricks system tables as well, because system tables provides a great way of getting down to the fine-grained view on the Databricks side, but you can't relate that to the compute resources that are happening in the cloud itself. And so there's a gap there. In terms of optimization, it's very limiting. Now, I do know that the cloud vendors have some sort of like compute recommendation engine. They all have a different name, but they're all about the same. Looks at your workloads and will say, instead of using this extra large, you should be using this large. When you're using this for a modern data stack like Databricks, where each of the worker nodes and driver nodes are doing different work, it doesn't actually work. And so I've run in with a lot of customers who thought that this would work, and they've tried it on the workloads, and it led to disastrous results. So from an optimization standpoint, it really doesn't move the needle when it comes to Databricks workloads. Last but not least, this information does come in batches. So what Microsoft, AWS, and GCP do is they get all this information, and there's a delay. Sometimes it can be a few hours, sometimes it can be a day plus. So for real-time use cases, being alerted when somebody spins up that very, very expensive job, you won't be alerted until after the fact. And for govern/operate use cases, that can be no bueno from that perspective. So to recap, how these tools compare for FinOps specific use cases, if we take the inform stage, Databricks system tables provides really good fine-grained granularity on costs and attribution to specific users and departments, but the focus is only on Databricks. For Cloud Cost Explorer, the benefit here is it does provide an all-in cost, but it's at that service level. So here's your VM spend, here's your Databricks spend. And if I want to get even more granular, you don't get that out of the box. When it comes to the optimize phase, Databricks does very well by providing access to deep telemetry data to enable experts to find these inefficiencies, but it does require that subject matter expert. So there needs to be some manual effort to be able to do this. And at scale for some of our large organizations, there could be a lot of opportunities that go awash because there's only a certain amount of resources that can actually do this work and find these inefficiencies. On the Cloud Cost Explorer, I actually had to downgrade this to red because it is, while they do have some optimizations at the VM level, it just does not work for Databricks use cases. Last but not least, operate/govern. Databricks system tables, again, does have some great alerting capabilities, but it does require manual effort to set up. And it's really limited to what Databricks sees. So if we wanted to set up alerts on when a spend from an all-in cost perspective, you can't get that from Databricks itself, system tables that is. And Cloud Cost Explorer, again, you could also do the same thing, set up alerts, but it's going to be scoped at the service level, and you're going to have that latency due to the batch processing that's happening in the background. So it's not very helpful in real-time use cases. Now what I'm going to do next here is I'm going to walk you through how FinOps teams are automating these best practices from inform, from optimize, from operate with a platform like Unravel. And let's start there. So I'm going to go ahead and update here. So what you're seeing here now is Unravel data actionability platform, specifically in this case for Databricks. We're going to start here at the Cost Explorer, which is all about providing visibility and details into costs. And more specifically, I'm going to be here at this drill down subtab here. What you're seeing is a chargeback scenario, right? So I can look and understand in the last 30 days, where has my resources and spend been done at the cluster level? I can look at things at the job run level. These are Databricks specific terms that we can actually look at. And customers of Unravel love the fact that this is actually filling in a gap of showing FinOps observability on these Databricks terms. We can also look and filter by workspaces. I don't have any filters set up right now. So we're looking at essentially all the workspaces that are set up in my environment. And I can also do things such as grouping by workspace. So if I want to understand where spend is going on there, or if I want to, get even more granular and understand where my spend is going in from a user standpoint, I can do that again out of the box. Now, what you're seeing here in this next panel here are three graphs. This first one here is all about DBU consumption, which is what Databricks uses to charge customers. And so we can get a picture here and we can understand who our biggest DBU spenders are in this last 30 days in my environment. The next one you see here is cost. Now, it can get confusing because DBU is a metric that Databricks uses to charge from a cost perspective. But the cost that you're seeing here is actually the all-in cost. So it's talking about the DBU that you're spending per job. It's also talking about the underlying instances, such as like the VMs. It's taking that into account as well. So if we want to start tracking things from an all-in cost perspective, we can see that here, and that can potentially show a different view from that perspective. And then we've got cluster sessions, which can just show the frequency of sessions, and so that's a good metric to see how busy things are. And then down below here is the same information, but in a table format. Now, one thing that is not very apparent in this view is that as soon as Unravel sees the job, so in real time, we're taking this information, processing it, and we're actually displaying it here. So this isn't a batch process. All the jobs, when you start seeing it, starts filling up the screen, and we start enabling some more of these real-time use cases, which is going to start really playing out when we start talking about the operate phase. But from an informed standpoint, to really understand use cases, where are my biggest spenders? What is the all-in cost? How can I track this in real time? All of this information you get from just installing Unravel in your environment. So very, very turnkey from that standpoint. Now, the next phase is optimize. And this is great that we can identify who our top spenders. And so in this case, this particular user looks like he's a big spender in my environment. Now, to showcase what Unravel can do for the optimize phase, I'm going to go ahead and click on this optimize, which is conveniently going to just take me here to the compute tab. So now I'm seeing all the jobs, again, very specific to Databricks. I'm going to focus in on this inefficient subtab here. And what I'm going to do here is actually just, you could see one of many events here. And these are all inefficiency events, which will make more sense here once I start clicking in. But for today, I'm going to go ahead and click on this node right sizing event. And you can see here, it says, see which cluster instances can be sized right and its impact on cost and time improvement. So let's go ahead and filter there. And now I can see a list of jobs here. What I'm going to do is I'm just going to just pick the first one here. And when I go in there, I can see I'm in a different view. I can, from an observability standpoint, I can get information on the specific job, but we're a FinOps team. And right now I'm looking for saving costs. And where I'm at right now is this analysis tab. Think about this as a Databricks expert in the box. Behind the scenes, Unravel's purpose-built AI is consuming all this information from logs, system tables, the Databricks API itself, doing its analysis. And the output that you see here is first identifying if there is an efficiency. For today's demo, we won't cover bottlenecks. We will do in a future demo. But for today, we will focus in on this efficiency analysis here. And more specifically, if I go and expand the save with node right sizing recommendation, you can see that there's some analysis that was done. In this particular case, we see that there is a driver node recommendation, again, specific to Databricks and the type of VM type that is only that's specific to Databricks itself. And it's quite simply put, and let me just go ahead and look at the worker node here. we can see that as an example, we can show the current instance. So in this case, I picked this particular instance. I can see memory, core, price, so on and so forth. There's other things that are factored in here too. We just really bubble up some of the main data points here, but we're all about saving costs here. And in this particular case, all we need to do is select this option 1 to save potentially about 14.24% just by making this recommendation. So let me recap what we've shown here so far. If I'm on a team that's looking for areas of optimization, what Unravel's giving me right out the bat is the mean time to identify. We're identifying that there are an area for optimization just by the title here. And to fix and verify, well, more than likely to root cause and fix, which will ultimately lead to verifying, we've done the analysis for you. And so based on learning the patterns of how this job is run, we're going to make this recommendation. And it's going to solve things from a cost perspective. But at the same time, we know that customers will not trust our recommendations if we are impacting performance negatively, or even worse, failing the job. So being in this industry, Unravel being in this industry for 10 plus years allows us a lot of, time to really train our models to make sure that we are sizing most importantly from a cost efficiency standpoint in this case, but at the same time, making sure that we're not losing the trust in our end users by negatively impacting performance or stability. So from an optimization standpoint, this becomes very powerful for use cases where let's just start by what Unravel tells us where we need to optimize. And then from there, we can go ahead and take action. Now, finally, let's talk about operate. Now, everything that you're seeing here so far, again, just comes out of the box from with Unravel, very powerful. The last one is how do we operationalize this? How do we make sure that the organization is applying the best practices? I'll even just start here, not even from an automation standpoint. What we have here right now is, if I just zoom out here and remove the user here, we're looking at all of the jobs that are being submitted in a Databricks environment with multiple workspaces. We're identifying where the inefficiencies are. And then from there, we can actually identify who the users are. So if we need to have a conversation with specific users, we now have this list of jobs that were inefficient and who the users are. So if I'm trying to build a center of excellence, this is a great way for us to have a very technical conversation about some developer's code without actually knowing what the code does, because Unravel is telling us that this is something that is a user behavior issue, and we need to start setting up some governance and guardrails from that. So we can just do this even just by looking at the data itself today and having a simple conversation. Maybe it's a Teams message or Slack message, and actually start the conversation of just log in to the URL and do what Unravel's telling you. But we could also automate this in many ways. For today, I'll show you one. The way that we're going to do this is we're going to actually set up auto actions. So auto actions is a great way for us to, as the name implies, automatically do something based on some sort of event. I'm going to do a very simple use case. I'm going to say, I want to set up a policy at the Databricks job run level. And quite simply, I want to know when somebody submits a job that has an all-in cost of $1,000. So if it goes over $1,000, I want to do something. I could set up additional parameters here if I want. I'll keep it simple. I could also set up scope. So if I want to do a specific time or user, I can do that as well. But we can also just set up a simple email, or maybe we post to Slack or Teams, or maybe we post to ServiceNow or Jira. But you've got the trigger up here, in this case, an all-in cost of $1,000. So as soon as that happens, let's go ahead and trigger that email. And we'll go put my sample email here. I'll go ahead and click create. And now you have Unravel applying that governance. So whenever somebody submits a job that is over $1,000, this all-in cost again, we can now start automate this process and having Unravel work for you and start really ensuring that we are firing on all cylinders on the operate/govern phase. So in summary, we covered best practices outlined by the FinOps Foundation. We showed how customers are applying these principles with out-of-the-box tools. And finally, how Unravel can make life easier for FinOps teams who want to operationalize these best practices at enterprise scale. Thank you.